Ready? And
Action.
Action. Like always.
Let's
So
go.
today we are going to talk about how to choose a container orchestrator. Yeah, Omer,
Right.
we will.
Yeah, that's correct.
Okay. Okay, so this session is continuing our previous session where we only talked about what is a container orchestrator, what are the possible container orchestrators that we can choose from, like EKS of Amazon's, Kubernetes, AKS of Azure, GKE of Google, and Omer really explained like
A
which
little bit
one is
about
which.
serverless. Little bit.
Yeah, and a bit, we'll talk here a bit of serverless, but not too much. And today we'll talk like how we're actually going to choose the proper container orchestrator for a business need. So Omer,
Yes.
take it from here. Like, let's see how you want to start this one, because this one is going to be like crazy, I think. So go ahead and shoot your stuff.
Okay, let's start with the fact that we're building on top of the previous session. So if you haven't watched it, I suggest you do, because we kind of went through Kubernetes, ECS, pros and cons. The thing we didn't touch is Hashicorp Nomads. We did mention it. One of the benefits that I think is important to mention about Hashicorp Nomad, beyond the fact that it's from Hashicorp, which is a great place to start and a great provider to work with for any kind of solution, Nomad specifically has the amazing benefit of basically scheduling anything you want, not only containers. So if you have jar files, binaries, basically anything, it can schedule. I even think they don't call it a container orchestrator. Well, they don't even call it an orchestrator. They call it a scheduler, because that's what it does. It schedules stuff as if you would with containers, but anything. Again, jars, binaries, anything you want to run, you don't have to wrap it in a containers, and sometimes there's a good reason for that. I can think of, for example, if you're running jars, which is probably running on JVM and it takes long startup times, maybe you have a good reason to run it on top of a machine rather than inside a container. So you can do that with Nomad. That's to start with. What's up next?
Just to be on the safe side, so Nomad is an open source project by Hashicorp,
It is,
right?
It is, yes. Mm-hmm.
Okay. So if I come with, if I have like a background in Terraform, will it be easy for me to use Nomad? Maybe.
I'll start by saying that Hashicorp, much like Amazon, would make your life much easier if you use them as a suite of tools. Like if you're going to use them and you're going to really invest in it, you might want to consider Consul and Vault around Nomad. You probably want to use Terraform to provision stuff. It'll make your life easier. You don't have to. In terms of knowing it, so Hashicorp has their own language, HCL. Not very complicated. It's not like it's basically learning YAML with a little bit more functionality, because you can do more stuff that YAML can't. But not very difficult. So that wouldn't be a reason. It would integrate really easily with all other tools. So that is a good reason.
Okay. You know, a few days ago, I think, 2 days ago, so I used the whole time to build Windows containers, you know, your favorite operating system.
Oh,
so
no.
to build the Windows AMIs, you know, Amazon images. So I used EC2 image builder. And
Rather
it took
than
me
Packer.
time. Rather than Packer. And then I decided that no way, I can't do it in the UI anymore in the console, because it took too much time.
Mm-hmm.
So I decided, okay, so I know Terraform. Let's see how Packer goes. You know, I already know the HCL. I know the base of the language. So let's see how it goes. And Packer was amazing. You know, it was like I don't know. I just spawned a new image for like it took like maybe 15 minutes, 20 minutes to really understand how it goes, because I had this background in Terraform. So that was great. You know,
Super
really
easy to
love
reproduce.
Hashicorp's,
It just makes your life a breeze. Yeah.
Mm-hmm.
Amazing.
So kudos to Packer, you know, along the way.
Kudos to Hashicorp.
Yeah. Okay. So let's focus. Let's bring up the topic. So the first topic is when to choose a proprietary. Okay, a proprietary container orchestrator like
Proprietary.
ECS.
Hard words.
Proprietary. Yeah. Sorry. Yeah. we are training here over our English. You know, we're also doing like an English lesson over here.
That's the entire
So
point
we'll do
of the
like,
session. Yes.
ECS. We'll talk about ECS. Can you think of another one that is like specific to a cloud provider? Maybe.
So I don't
maybe?
remember the exact names. So Google has one, and Azure has one, and Ali Cloud has one. I
So
think
we focus
most
on
of them.
ECS because we both know it, right?
Yeah, it's easier for
I
us, but
assume.
you can take what we're saying to any other cloud provider. I think we did mention last time in the other session that basically having yourself, if you're really invested into your cloud provider, let's take Amazon, for example, because that's the easy one. If you're invested into things like DynamoDB and RDSs and CloudFront and API Gateway, whatever other service, you're already kind of married to your cloud provider. Using the orchestrator it's not a big deal. At the end of the day, you're just using another service. And let's take it a step back. You're using containers. The same containers can run on ECS, they can run on Kubernetes, and even they can run on Nomad. So it doesn't really matter. As long as you're building containers, that's easy peasy, right? So now we want to discuss when to choose. When would I go for Nomad? When would I go for Kubernetes? When would I go for ECS? So I mentioned in the last session that for small projects and easy projects, I go with ECS because it's easy to provision, much easier than EKS. If you're not familiar with Kubernetes, there's a huge, very steep learning curve. I wouldn't go there if you don't have the skills in the team. Having that said, I don't think ECS is only good for a small project. I think ECS is great for any kind of scale. I built enormous scales on ECS and it worked perfectly. I don't want to say things I'm not sure of, but I'm pretty sure Netflix maybe started, maybe still are running on the control plane of ECS on Amazon, but I'd have to be fact checked on that. So scalable, great, easy to work with. And then again,
hang on with that. So ECS, double clicking on the development process. So I think that for each container orchestrator, I would also like to concentrate, like to focus on the development process, because ECS, I think they also made a big progress to make it also compatible with Docker Compose, which also has an extension, a plugin of, deploying from Docker Compose to ECS. I haven't used it yet. It's not new. I think it's like more than a year out there. Generally available for more over the year. But how is the development process for you? Like, how would you say the development process of containers and orchestrating between them with ECS? Would you consider it fast?
Fast as in comparing ECS to Kubernetes in terms of dev tools?
Yeah, comparing to Kubernetes, yeah.
Okay, so I think it comes down again to what you know about either of them. If you're really familiar with Kubernetes, not familiar with ECS, maybe it will take a little bit of more time. In terms of tooling, like dev tooling, so maybe in Kubernetes you're writing YAMLs. I hope you don't, by the way, because that's not how it's supposed to look. You're actually expected to build containers, then use some kind of continuous delivery tool, style Argo or whatever it is to deploy into the cluster, or create your own scripting mechanism around it. Same for ECS. So ECS has this mechanism of task definitions. So task definitions are kind of the template, same as you would build a template for a deployment in Kubernetes. So you build a task definition, and that has the image and the variables, parameters, volumes, anything you can describe as part of kind of a pod. So not a pod in Kubernetes. In ECS, it's called a service. That's the difference. So what you need to do in order to deploy a new version is take the last task definition. That's one way. Take the last task definition, copy that, duplicate it, change whatever you want to change. Probably 99% of the times it would be changing the image tag because you probably built a new version based on your
Usually
CI server.
It's just create a new revision. That's it. It comes up to create a new revision.
Yeah, basically.
Just change the image name.
And updating the cluster, and then
How
ECS
do you
takes
deploy
it
with
from there.
ECS? How do you do that? How do you deploy to ECS?
Okay, so I'm using a tool that's called ecs-deploy. It's an open source tool on GitHub. So ecs-deploy, funny thing, I don't know how it's still there, but there are two different tools. One is written in Bash, one in Python, I think.
So mine is in Bash. Which one do you use? The Python or
I
the
think
Bash
the
one?
same one. I think the same one. There's a little bit of difference. In one,
Cylindrical something, right? Something with S.
I can't remember,
We'll
but
post
one,
it down.
one doesn't let you use update environment variables, and the other doesn't let you roll back or something like that. I'm not sure. So
Okay.
I kind of need to play with them. I never thought of building my own, but it's not that difficult. By the way, I don't think either of them is the best solution. I think the best solution is going through CloudFormation. CloudFormation is built for that. If you build your cluster in CloudFormation and the services and the task definitions and everything, all you have to do is update the stack for CloudFormation. Then when you update the stack, it does the entire thing on its own. It creates a new revision, it updates the whatever you want, the variables, the parameters,
cool.
the volumes. I used to do that in the past.
But it also rollback, does the automatic rollback to the previous version if
yes,
it fails to deploy.
Yeah, that's part of the state management of CloudFormation, yes. Mm-hmm.
Okay, so good.
So that's a nice thing. Still, I use ecs-deploy because we mostly use Terraform, and ecs-deploy, I'd say it's far easier to just run the command rather than building the entire thing in CloudFormation, updating the stack. It's just easier. You run it, it takes the last revision, creates a new one, updates whatever you want, and that's it, deploys. So
okay, and
we
locally, we talked about the development process. So locally, how do you imitate the ECS cluster locally, the ECS services locally? Do you use Docker Compose to do that?
It's hard to say. I'll just mention that most of our work is around serverless. It's not around containers. The developers that do, yes, they run the containers locally. And the more advanced ones, I'd say, that are actually searching for the good solutions would use Docker Compose. Maybe it's worth having a session that we can share our screen for a couple of minutes and kind of present a good dev workflow with Docker Compose. By saying a good dev workflow, I mean provisioning all the supporting containers. Maybe that would be Redis, Postgres database, whatever that is. And your application, instead of constantly building it into a container, I'll just launch a container that lives in the background and mounts your local work disk. And then you can keep using your IDE on your computer, change the code, whatever you want to do, and the process runs in the container. So you get the same feeling as you would in a production or / staging environment, but you're still running in your computer on a container, right?
Yeah, and also all the developers, you don't need to tell them like, okay, guys, I need you to install this and this and that. Everybody works with the same image, and that's it. We got all the applications the same for all developers. Everyone works with Docker, works great.
That's the power of containers, yes.
Okay, and if you compare that, the development process, even before going to the cloud, let's compare it to Kubernetes. So if people work with EKS or, I don't know, even self-managed Kubernetes in the cloud, how would you suggest employees, DevOps engineers, to use Kubernetes locally? I use Minikube, for example. What do you use?
Actually, Minikube is great. Usually when companies tend to grow, the amount of services and stuff they need to provision and work against grows so much that it becomes almost unreasonable to run it on your computer, right? If you have, let's say, I wouldn't even go for a big number, even if you have 50 and 100 services, but let alone 10, running 10 containers that run different applications on your machine is a lot of resource consumption, might not be the best thing. If you're running something very constrained or kind of containerized in the same area, and you can run 2-3 different applications, cool, yeah, sure, run Minikube. If you're running a huge cluster, and normally when companies go to Kubernetes, I hope it's because they have a large scale of containers that they need to manage. And running it on Minikube is not always the best solution. So I'd rather launch...
I have a solution for that. Before you give another solution, I do I launch only the services I want to develop in Minikube, like a hybrid solution. So you talked about hundreds of services. So let's say one of the environments, let's say production contains 500 services, 50 services, whatever. So what I do, I connect my computer with development environment. All right. And let's say over there we got 40 services.
Exactly. That's what I wanted to say.
No way. That's what you wanted to say? No way.
Exactly.
Yeah.
I won't go to the effects again, but I'm going to clap in the background. It's too annoying to edit.
We thought the same. Yeah. I thought you got like an awesome solution, because mine is like, I felt like it's too basic, It's like just provision the ones that you want to develop, and the others used from the cloud.
There's no magic in DevOps, is there?
Amazing. So we thought the same, but I want you to explain it like in a better way, because we interrupted each other. So now say the solution that you said.
So exactly like you said, if you want to work locally with, let's say you have a Kubernetes cluster and it has X number of services, the easiest thing to do easiest air quotes thing to do would be to deploy the same thing on Minikube locally. And then you have the same cluster that's running in production or staging running locally on your computer. And you can just talk to the same APIs and do whatever you want to do and expect the same results. But when it grows and you have a lot of services, it's time and resource consuming. Run just a microservice or 2 or 3 or whatever you need to work and change. Wherever you need to make changes, run that locally. And the others, you'd need to connect to a remote environment. Easier said than done. You'd have to worry about all the routing and the wiring, and that's something a DevOps engineer probably would help you do. But that's the main idea. You want to point something that you're not going to change, point at an endpoint that sits in the cloud or a remote environment, and things you do need to change, keep locally and work on them.
And that also relates to our first or second session where we talked about ZTNA, remember? The Zero Trust Network Access.
Yes.
So if you provide a good Zero Trust Network Access or a good VPN solution, then your developers can use the development environment easily from their computer. So that's also related, like everything is related, you know? You do this, it comes to that, so yeah.
Correct. So I'll kind of pull us back to the main line, which was, how do I choose? Where do I go to? So we discussed different benefits of Kubernetes, different benefits of ECS. So that's a great benefit of Kubernetes. You don't have, of course, you can run the same containers you have in ECS locally, but you'd have to do something. You'd have to work a little bit more. Whereas in Kubernetes, it's simple as taking the same thing and running it on Minikube locally. On the other hand, when you go to ECS, it's integrated so well with Amazon services that just provisioning a cluster with services and tasks automatically is sending logs to CloudWatch and metrics to CloudWatch, and everything can be immediately visualized in a dashboard. So everything is so easy to the word I'm looking for is everything is out of the box. Most of the things are out of the box, whereas when you launch an EKS cluster, you need to install stuff. You need to install agent for log collectors, and you need to install things for visualizing and aggregating and stuff like that. It's not hard. Again, Kubernetes has this huge ecosystem of Helm packages and other things that you can install immediately, but you have to do something. So it's kind of a difference. If you want something really easy and quick, I'd go for ECS, or you really invested in Amazon, I'd go for ECS. On the other hand, if you have needs to run your cluster with, let's say, an easier manner locally, go with Kubernetes. Specifically, if you if you want in the future to move to other environments, maybe you have to deploy because customers are asking for that. You want to work on different clouds. Kubernetes would probably be easier because you can use the same configuration and move to another cloud. It's not just pick your things and go. Things would be different, especially if you're running on the proprietary ones. If you're using EKS, you don't just move to GKE. You need to do some kind of modification. You're probably not using the same volumes for storage, not using the same.
This is exactly what I want to tell you. I wanted to bring up Zesty. You know, let's talk about Zesty for a second. So for Zesty, if you create a Helm chart which includes volumes or persistent volumes, persistent volume claims, the underlying system, you know, the volume itself, if it's GP2 on Amazon, if you move to Google, I have no idea what they have over there, but you gotta change that. So yeah,
right. So
that would be a challenge.
Let's double click just a second into Kubernetes storage. Okay, Kubernetes storage used to run. We need to mark this point. If you're getting bored, you can jump ahead. When Kubernetes provisions storage, up until around today, you used to build on something that's called the CSI. Up until today, we were using in-tree CSI, meaning if you go to Kubernetes in GitHub and search for EBS, you'd find that it's in the code. Kubernetes has a notion of EBS in the code, so when you run against Amazon, Kubernetes knows how to provision an EBS. It would know the same thing with Google and Azure and a lot of other provisioners. That's the technical term for the component that provisions storage. Kubernetes at some point last year decided that they want to remove all in-tree provisioners or CSIs, and they want to move to proprietary ones, meaning they tell Amazon and Google and everyone else, we're taking these out, it's going to be deprecated, build your own. And so today, if you want to use it, you use Amazon CSI. CSI, let's try to remember what it says. Container storage, blah, blah, blah.
I don't know. Container storage. something.
Interface. That sounds very good. I don't know.
Yeah. You can. It's also crime scene investigation if you want, but I don't.
Oh,
think
that
it's
sounds
right?
better.
So CSI container storage interface. You are right, amigo.
Fuck
Good
yeah.
job.
Okay.
Yeah.
I'm not allowed to curse here. We need to edit that. Not gonna happen.
It's there.
Fuck yeah. Talking about Kubernetes storage. Not
ahead.
part of the session. Okay.
Yeah. Not made for children. Okay,
Yeah.
we edit it on YouTube. We say it's not made for children. That's why.
Exactly. I want to circle back with that thought in mind of CSI to why would you use Kubernetes? This is part of its flexibility. When you use Kubernetes, you have the flexibility of running anywhere and everywhere. And the CSI, in terms of storage, you have CNI for networking and lots of other components and layers that take care of stuff. And stuff, air quotes, Kubernetes doesn't care. Where are you running? It has, different layers to run in different places. So again, coming back to storage, when you run on Amazon, you have the Amazon CSI. When you run on Google, you have theirs, and that would manage the GP2, GP3, and whatever other volumes you want to run anywhere. So coming back, if you need to be flexible with cloud providers, locations, maybe you want to extend yourself to physical servers you have in the basement for some reason, I'd go for Kubernetes. That's the more pluggable one. It's easier to write controllers, which is another session we'll have in the future, is how do you create operations based on controllers and operators and CRDs. That's another set of terms we'll talk in the future when we go deeper into Kubernetes.
I also want to talk about Helm about that, to mention Helm. So if you want to indulge your developers, for example, what you can do, you create a generic Helm chart with helpers and everything, and we'll get to that, in the future. But you can create a Helm chart which has deployment, service, and ingress, like everything you need. And then when a developer tells you, listen, dude, I need to provision a new service. How do you do that? So you tell them, listen, I got this Helm chart. You can use that, insert your stuff, like the image name and everything, and you got all the CI, CD, everything ready out of the box that you've created it. And then you can replicate your work. So I think you also did that for a company. I'm not sure we are allowed to say its name, so let's just not even say it. But you did that, right, Omer? I think you created like a generic Helm chart for one of the companies that you provided services for, and it was like many services. And it worked.
If we're talking about the same one, it was a storage company, right? Right?
Yeah.
Okay, good. So it was exactly. So that company specifically had to, the cluster was the actual product. So you'd have to provision the cluster on the customer's side. So in order to do that, we need to provision the cluster. We did that with a system of Ansible scripts we wrote around it. And then the actual provisioning of containers in the entire system, because it had different pods and daemon sets and stateful sets and whatever, that was with an umbrella chart with Helm. So the umbrella chart, you said Helm install whatever, company.com, and that would call a lot of subcharts, which would call a lot of subcharts, and you'd have like this huge umbrella of charts, and that would install everything with one click. So that was pretty cool.
And I think we've just proven we believe in NDA, right? We believe in our NDA.
Yeah, kudos
when we
to
sign
us.
it, we believe in it.
Kudos to us. If you hear us, our previous boss, there you go. We kept our word.
Yeah, when we sign it, we mean it. We don't mention companies.
Exactly.
Okay, Omer. So we talked about local development of ECS, where we use probably Docker Compose. I'm not sure we're doing conclusions, just doing a recap. Okay, so a recap for what we did.
I think it's good time for a recap and a quick summary here.
Okay, so we got like ECS locally, we would develop it with Docker Compose. If we use Kubernetes, we'll probably use Minikube so we can develop locally and then provision it on any cloud, more flexible than using ECS, because ECS is for Amazon. And if you use any other how do you say it?
Proprietary.
Yeah, so if you use a proprietary solution of containers like ECS, you'd have to adjust it more. You have to do more changes if you move between clouds. It's not often you move between clouds, but in case you do, in case you provision your service in your customer's cloud, then you probably want a more flexible solution like Kubernetes. Mm-hmm. Okay, so that's like about the recap. And Omer also talked about storage provisioners and the differences that can rise when you use Kubernetes and provision them in different clouds. We're not going to do a deep dive for that. Let's leave it aside for a second. Omer, anything else you want to focus on?
Yes, two quick points. One was the one I started with, Hashicorp Nomad. If you have kind of more extreme deployment, maybe you want to run your binaries as is, maybe you don't want to be constrained into containers and you want to run different stuff, again, jar files, try out Nomad. It's great, scalable. It knows how to work with fluctuations in the connections between the pods and the masters. Try it out. And the other thing that we did not discuss, and we will have a session about it, is serverless. So serverless is not an orchestrator. It's just a way to run your code in the cloud, but that is another option. I just want to throw it out there as another option. When you consider containers, you probably want to think of serverless. Let's just keep it at that. It's another solution. We'll have an entire session discussing serverless, the benefits, the cons, the pros, and everything around it.
Okay, so Omer, for the next session, you're going to prove me, okay, that's it. We talked a lot. We got to see some screen. We do some cool editing. As you can see, guys and girls, yeah, we got like, our studios got better, okay? So the ones who just listen to us, I hope you listen to us and it sounds very good. But the cameras got improved. Omer already got everything set up for him, but I also improved here everything, and we're trying to make it even more professional every time. And every time we make it even longer. So we talked about making it shorter, but we decided that let's just talk. So we're on 26 minutes now and counting, right? We're going to be in 26 minutes in 5 seconds.
Yeah, good for us.
Yeah, so next time, Omer, I want you to prove me why Nomad is a good solution, because I have no experience with Nomad. I did a tutorial like, I don't know, a year ago, I don't remember. And I want to see why Nomad is a good solution for a container orchestrator. Okay. So that's our next solution, session.
Cool.
Anything else, amigo? Or should we wrap up?
I think we're good. Let's wrap up. Thank you for tuning in.
Okay, thank you everyone. Bye for now.